Hello everyone, today I want to explain 4 problems A, B, C, D from Codeforces rounds 891 div 3. So first problem, array coloring. This was a pretty straightforward problem. You are given an array consisting of n integers. Your task is to determine whether it's possible to color all its elements in 2 colors in such a way that the sums of elements of both colors have the same parity. Same parity means that if you divide it by 2, this 2 remainders should be same, and each color has at least one element colored. For example, if the array is like this, we can color it like this, where the sum of both elements first is 6 and then another is 18. So if we divide 6 by 2, it's 0 remainder, and the same for 18. So I think you got it, you got the point. For example, for this case, there is only one rule. If there are if the number numbers that are divisible by 2 are not divisible by 2, I mean if the number a is numbers like this, if you count numbers like this, for example, let's call it count. If this count is divisible by 2, then answer is yes, otherwise no. So because if you have for example, in this case, this 2 and 4, this easily eliminates, because if you don't put even nothing in the other side, it's just same parity, this also. So now we have we left only with this odd parity numbers. So if the number of odd parity numbers is odd, so the answer would be yes. So now, so it's if it's until 50, so we can just add all of them. So we go, we need n, sin n, and then if you don't know what I define it in the above, from till n. So we need another one. This will be 0 at first, just integer, just let's call this long to not to make problems. So we'll just add this to sum. And now if sum divided by 2 is 0, answer is yes, otherwise it's no. So as you can see here, we try checking this the sample test case. So sum plus this. Yes, no, yes, yes, no, yes. So it's same. We'll submit it. So this was pretty straightforward problem. So now we will move on to the second problem. This second problem was much of implementation problem. Is maximum rounding. So given a natural number x, we can perform following operation: choose a positive integer k and round x to the kth digit. Note that the positions are numbers from right to the left. So read to the statement, then I will explain. So I think you know how to round a number. It's just simple math. So according to this, simple math. For example, if we have this big number, what we can do, we have to go through from right to the left. So for example, this 7 is bigger than 5, so we will eliminate this and add 1 here. So 7 is bigger than 5, so we will eliminate this and add 1 here. So this 5 itself is bigger, so we will eliminate and add 1 here. Sorry, 1 here, and this is not bigger, so we will leave it, and this is bigger than 5, so make it 0 and add 1 here. So in that case we have to remove this to 2 because we rounded it. So 3, 1, 2, 4, we don't care about this, so it's at least 5, so we will eliminate this and add 1 here. So at this case we have to do the same for this 5 too. So this we will eliminate 7 and add 1 here, instead of 7 we put 0. So 2 we don't care. This is bigger than 5, so we'll eliminate this, add 1 here. So now this will be 0, this will be 0, so this is 9. So we'll eliminate this and add 1 here and put 0. So as you can see here, this is the answer. So now B problem is much, as I mentioned before, B problem is much of implementation problem in this round. So the explanation was simple. Now we have to implement this thing. First of all, we will get this as n, and we will add a 0 for the cases, right, like this. For example, if it's 5, if we eliminate this, we should have some place to add 1, so we are putting 1 before n. So now we should go through from right to the left, so -1, so now we will check if this is to turn this into integer, we will subtract this character 0 is at least 5, then we will round it and this becomes 0. So now we will get another index and call it j, where we so as you can see here, we have some cases like this. For example, 1999. What we have to do, we will eliminate this, we have to eliminate this, we have to eliminate this, we have to eliminate this, and put 1 here. So for this, in C++ there is already made function find last node of, and we will search it with 9 I minus 1. So it's simple. It's from the index I minus 1, find the first of node 9. So it can be 8, 0, 1, anything, but not 1. So now at this index we will add 1. So now we added 1. In this case we did this thing. We did this 0 and this 2, and we have to eliminate this to 0. For this there is a replace function. It starts from index j plus 1 to the end dot length, because we don't know until what it is going, minus j and n dot length. So we have to be sure that this eliminates all the zeros, minus j minus 1 and to 0. So it's j plus 1 and dot length minus j minus 1. So I think that's correct. After this we can just input. Now we have to check if the first element is 0 or not. If this is 0, we will print from the first index. Otherwise we will just print it itself. So now we will give a try. If you're confused, ask in the comments, I will try to help. So this worked. Now we try submitting code for problem B. So it's running. It's accepted. So as you can see, it was much more of implementation problem. Now we will move on to the problem C. To be honest, I think this was also a much of implementation problem. First read this problem yourself. Now I'll shortly explain. If this array is a array, you will pair all the numbers and put minimum of them and shuffle it. We have this B array. Now we have to find out array A. So now, as you can see here, there is some type of consequence like this. For example, 1 3 1. So what you are seeing here, 3 is participating here once, so 1 is twice, so this 3 1 and it's 3 numbers, and so there is something else. So we can, what is the maximum we can put? 10 to the power of 9. So we'll put here it, and 2 10. What we can put? This saves us. So also we can put 10 itself here, but it's just another thing to do. It make it easier. So in this case, 7 is at once, 5 is twice, and 3 is 3 times. So this, and it's 4. We will add saver. So as you can see here, in this case we have 2 once, 2 twice, 2 once, twice, 3 times, and 4 times to itself. So what else we can put? Our saver. So I think you got the point. We have to we have to add all of them into one map, so that we can find how many times which one was participated. So long this. So this formula is given here, and times n minus 1 divided by 2. So now make one map, long to int, and call it helper. So then with rep is defined here. If you're confused, now this is not with m, this is not with n, with m, because we are not getting a here, we are getting b. So I put it with m. Now one just. So now help the inputted numbers, this in the map will be added 1. So now we will make one vector to help us during this journey. So this is a original array. We are trying to build this array. So index, I think, could help us here. We start from the end. Start from the for example here it's if it's 5. For example here if it's 4, we will start from 3 times participated once. There's 3 participated 3 times. So that's why I put in int to be n minus 1. So now we will go through all the elements of the map. The benefit of map compared to unordered map is that it is binary search tree, so that it is already sorted. We don't have to take care of it. So that's why this is better to use map in some cases. Element dot second equals IND. So we will just push back to our original array, and IND minus is we will increase this decrease this by 1. Otherwise our second would be we will go call it sec. It's second element dot second. So while this second is not 0, we will push back to A, and this element's first one. So now we will subtract IND from the sec, and IND gets decreased by 1 itself too. So all we collected all the elements of original A. Now we can call one added. So all number of all elements that have in the original A array dot size. So we will iterate through this A array and print its elements. So now for the elements we did not print, we will go through them with this powerful subtraction n minus edit, and see out this 10 to the power of 9, this 10 to the power of 9. 1 2 3 4 5 6 7 8 9. So here so we'll put new line. So that's it. We'll try checking this with sample cases. So I think problem is here. It's minus equals IND. Otherwise this while loop will not end. So we'll try checking this with Codeforces. It's problem C. Accepted. So now we will move on to the problem D. This I like the problem D because this was not that much implementation problem. Read the problem statement once yourself. So now if you want to go from U to V, you the path exists if this statement is true. So a vertex V is called strong if there exists paths from V to all other vertices. So we should check with all of them, or use some techniques. So now here, as you can see, when we can destroy this statement, so these two are not set by us, because when we will iterate through this, so now this should be as maximum as possible, because this to destroy the statement. So this should be maximum possible, whereas this should be minimum possible. So in that case, even if in this case it works, then we have no other possibility that we can stop this. So using this, we can put using some simple math. This equation becomes like this: AV minus BV. So this statement should be true. So we cannot change this, but we can choose this one wisely, that this helps throughout our journey. So now how we can choose this wisely? So we'll just set it to be maximum. So first get all information that we need: AN and BN. Firstly, so first we set this maximum to be minus 118, because that's the minimum possible value we can get from this equation. So now we get this and other values too, for values for B. So the maximum will be maximum of an X and AI minus BI, this statement. So then our answer was get with 0, and we have to go through all the cases to find ones which can satisfy this equation. So we eliminated this, made it easier equation to be like this maximum. So we have this to be set, and we can iterate through this. So we will just count it and print it. So if AI minus BI is at least MX, then answer will be increased by 1, otherwise nothing. So we will print it, answer, and put one new line. And one more time we will go through this to print its elements. Cout I plus 1, its index plus 1. So just this should work. If you have any problems to understand this, let's ask in the comment section. I will try to explain this. So I think this we forgot to put this one here, new line. One line can change a lot of things. So we will submit code for D strong vertices. Thank you for your attention. subscribe to my YouTube channel and stay tuned for more.